Today we're going to be talking about a specific adaptation that fish have developed over the years. So far we've already talked about evolution and how speciation occurs. This is how we're going to talk a little bit about the history behind arguably one of the most important organs that has allowed fish to occupy so many marine niches across the world. Okay? And that adaptation is the development of what's called a swim bladder, which has nothing to do with urine or pee or anything else. So let's get those thoughts out of our head right now. Okay? It's not about that. Okay? Fish have an amazing ability. Okay? If I were to throw you in a pool, right, you could swim down to the bottom, but you'd have to expend a lot of energy to get down there, correct? Likewise, if you sank to the bottom and you wanted to get to the surface, you'd have to expend a lot of energy to get back up, right? And you'd be spending all your time swimming. That's not to say you couldn't get down to the bottom and back up and down and whatever, but you'd be wasting all of your time and wasting all of your energy doing that. Fish don't have that luxury. They need to eat. They need to mate. They need to do all the things that fishes do. And if they're spending all their time and energy swimming up or swimming down, they wouldn't be very successful. So basically, fish have developed a swim bladder in order to maintain what's called buoyancy, that ability to remain neutral in water. Okay? So, on your paper it says, how do fish stay afloat, bestow energy to feed, mate, etc.? They have a swim bladder. What is a swim bladder? Okay? A swim bladder is an air-filled sac in fish that allows them to maintain neutral buoyancy. Okay? Meaning they are equal in the water. Okay? Air-filled sac in fish that allows them to maintain neutral buoyancy. Okay? And then they can expend their energy doing all the other things that fishies need to expend their energy doing. All right? Now, without a swim bladder, they would sink. Why? For the same reasons that we would sink, in that their tissues, their organs, all right, all that stuff is denser than water. Okay? So if they didn't have a swim bladder, otherwise they would sink because the tissues are denser than water. In the most simplest terms, swim bladders allow fish to float, okay, and not sink. In reality, they're connected to a lot more, as we'll find out in a second, but in essence, that's what they are. And they are found in the abdominal cavity of fish. They vary. They're not always in the exact same spot, and we're going to do a fish dissection, probably not next week, but the week after, I think we'll get to it. And if you do that fish dissection, we'll look for the swim bladder, and you can find it. It's always in the abdominal cavity, but depending on the evolutionary history of the fish and its size and some other factors, it can move around within that abdominal cavity, but it's always found in the abdominal cavity somewhere. And again, in essence, kind of already said this, but it's on your paper, they allow fish to achieve near weightlessness. Okay. When the swim bladder capacity is around 5 to 7% of the total body volume. Okay? A lot of fish achieve near weightlessness when swim bladder is around 5 to 7% total body volume. More than that, they would float. Less than that, they would sink. But when that air capacity, that abdominal cavity is extended just enough, right, to about 5% of their total body volume, that's when they achieve that buoyancy. Have any of you ever scuba dived? Okay? Those of you that scuba dive, you know that feeling. Okay? It's when you regulate your BC perfectly enough to achieve buoyancy in the water. All right? Okay, so that's what the swim bladder does, okay, in general. Now, fish can expel air from it, and they can increase air in it also to raise, all right, their buoyancy or lower their buoyancy so that they are moving up and down the water. But that's not usually how fish move about in the water. Usually they'll expend some energy to swim up or down and keep their buoyancy relatively even, okay? In different environments, that changes, okay? But overall, that's kind of like, in general, what they do, okay? Now, it differs between freshwater and saltwater. We're going to be talking about saltwater fish because it's marine science. But just so you know, freshwater fish generally have larger swim bladders. I'll get it. Hello? Megan?
Yes.
Yes. Sure. Megan, that will be forever immortalized on YouTube. Congratulations. The office would like to see you. Okay. So, what I was saying was fresh water fish have larger swim bladders. Why? Because fresh water is less dense than salt water. Okay? Fresh water is less dense, so you need a larger swim bladder. You have to have more capability to put more air capacity in you to maintain your buoyancy. Salt water, it's less dense, you're more likely to float, so you don't need as large of a swim bladder. Okay, and we're going to talk about that a little bit more when we talk about the evolutionary history of swim bladders and how they happen. Now, this is the main function of swim bladders, to float around. But they also can help fish hear, which is kind of weird. Because you're kind of like, why do fish need to hear? They're underwater. But how many of you have ever been in a pool or screamed or anything underwater? Can you hear it? Yeah. Now, sound waves travel very differently underwater than they do in air. For example, if we were all underwater right now, we'd have bigger issues than you being unable to hear me, but you would still be able to hear me, it just wouldn't sound quite like it does in here. Our nervous systems are all tuned to understand sound or to hear sound through voice through this air medium, okay? But underwater, you can still hear sound. And some species of fish utilize sound most often in mating rituals, okay? Or as a warning against predators, or as defense against predators, I should say, et cetera, et cetera. And the swim bladder helps them with that, okay? So besides allowing them to regulate, it also helps them hear and can help amplify sound in several ways, okay? The first way, let me write this in. Can also help fish hear. In 3 ways. The first way is it can act as a resonator, okay, for sounds made by other organs. Okay? So for example, some species of fish use their teeth to make sounds, and they can then use their swim bladder to kind of amplify through resonation that sound. Okay? And again, that might be, not all fish do this. Right? If they did, the oceans would be a lot louder. But some do, whether that's for a mating ritual or for something else. Okay? Some of them are using their swim bladders to act as a resonator for sounds made by other organs. That's part one. The second way is that they can actually make sound through their swim bladder by letting air escape through what's called the pneumatic duct. Make sound by releasing air through Okay? I don't know what this sounds like. I picture it sounding like when you let air out of a balloon. I don't know. I don't know how we would know. Okay? Okay, so escaping air through pneumatic duct can make noise. And then finally, some fish actually can vibrate, okay, their swim bladder wall with a specialized kind of drumming muscle. So they literally kind of beat it against it, which makes this drumming sound on their hollow swim bladder. Okay. So can vibration of swim bladder specialized drumming muscle. Now these would be specific, these would be like adaptations on an adaptation. We're talking about the swim bladder in a very general sense as a big adaptation that fish have evolved to survive in their environment. These would be individualized adaptations of individual swim bladders within a species. Okay? Not all fish do this. In fact, most fish, I'd say, don't. But some fish do. They use these swim bladders in these specialized ways. All fish use swim bladders for buoyancy. Okay? Question so far? Okay. The final thing that I want to talk about is how did the swim bladder come about evolutionarily? We've been talking about evolution. We've been talking about how species are created through different means. We've talked about how Darwin's theory of natural selection can explain how adaptations develop, right? And I want to try and explain to you how the general theory goes that these swim bladders develop. Because if you think about it, it's a pretty complex idea that you'd have this specialized organ to allow you only to float. How did that come about? We certainly don't have it. Okay? How did this come about in these fish? Okay? So the evolution of swim bladders. Okay? It starts with talking about, I'm going to get this right, teleosts, all right, or ray-finned fish. And these guys are kind of these ray-finned fish, kind of like your average fish when you think about a fish. Okay? And they have changed their lungs through evolution into swim bladders. So they originally, so they originally had lungs, and they have changed them into swim bladders over time through evolution. Okay. Part of this is because, wait, hold on. Before we get to that. There are two types of swim bladder systems, open and closed. Okay? Shallow water fish have an open system. And what this means is that in order to fill their swim bladder, they need to actually come up to the surface and gulp air. Okay? And in the shallows, this makes sense. Carp do this. Trout do this. Okay? Because they're living in an environment where they can get to the surface relatively easily without expending a ton of energy. So they come up, they gulp air, they fill their air bladders, all right? And then maybe burp out a little air if they need to, all right? Take in more when they need to maintain that buoyancy. That's an open system. They gulp in air at the surface to fill their air bladder. This is not how they breathe, mind you. They still have gills. They're still passing water, oxygen-rich water, through their gills and extracting the oxygen from the water at their gill sites to go into the blood. But they can gulp it with their mouth. Okay, and these are shallow water fish. Deep water fish have a closed system. And this means that they fill their air directly, or they fill their swim bladders with air directly from their blood. All right? It has to do with this. You've got an acidic environment. We won't go into the details, but they basically can compress air into that swim bladder through their blood vessels, okay, inside. Okay? So a closed system is when fish force air into swim bladder from blood. And therefore, there is absolutely no reason for this fish to go anywhere near the surface. Right? They don't need to. They don't need to. They can fill their swim bladder internally, so they don't ever need to gulp that air like trout, carp, or shallow water fish do. Okay? So knowing that, the conventional explanation then about how this happened was that evolutionarily, actually, and this always kind of surprises me, but this is one train of thought for why this occurs, is that in fact the ray fin and fish that we now think of in marine environments evolved from freshwater fish. Okay, so freshwater fish with an open system, those trout, those carp that gulp air, moved into marine systems, where then there was a new niche to fill, namely deeper water. Water that was so deep that it didn't make sense for that fish to come all the way to the surface to fill its air bladder, which has also evolved along with these species. Okay? And once that niche was there, then there was an adaptation for a closed system swim bladder. Closed swim bladder. Okay? So, on your paper it says, the thought goes that evolutionarily fish went from fresh water to salt water. Or went from freshwater environments to marine environments. And so this closed swim bladder filled a niche at greater depth. Okay? So now that fish are coming into environments where you're 100 meters down, 80 meters down, right? So now there's a new niche, there's a new drive for natural selection for this swim bladder closed system to occur. Okay? That's a general process. This occurred over millions of years. Okay? They don't know exactly. The fossil record gives some indication of how this occurred, but not a ton. Okay? Or only what is available in fossils. Okay? Questions on this? Okay. That's it for today then, on swim bladders. I will shut this off.